greater than 7, less than.
Wait a minute. pH value of
Pure
water.
water at
Pure water, right?
yes sir.
Pure water at 0 degree centigrade.
Yes sir.
Am I visible? Okay. Is the screen visible?
Yes sir.
And I am visible to right.
Yes.
So pure water has a pH value that is equal to basically pH equals to 7. Are you getting my point, Krishna? You know what water is neutral in solution, right? Water is neutral.
Yes sir.
Okay. And pure water is neutral. That means pH equals to 7. And if something is add in that like acid or base, it will be acidic or basic. Generally, pure water is neutral. That's why pH equals to 7.
Okay sir. So if there is a decrease or increase in temperature, will that affect the pH?
Yeah, it will. It will affect the value of pH. Basically, we will discuss about it when we will complete buffer solution. Actually, I'm going to write a sentence. Just see. Kw equals to Ka into, sorry. This is basically H plus into OH minus is equal to 10 raised to the power 14. And this value comes at 298 Kelvin. That means 10 raised to the 25 degrees centigrade. If we will increase or decrease the temperature, it will affect. And if concentration affect, that means pH will also affect. Okay, Krishna.
Okay sir.
Okay. So, Saif, am I audible to you? You are not speaking.
Yes, you are.
Okay. So, is everything clear? Was everything clear in the previous class? What is acidic buffer? Basically, we just covered only the acidic buffer, right?
Yes, sir.
So
Yes
I'm
sir.
going to revise it a little bit. Buffer solution first. What is buffer solution? So a mixture which resists the change in pH, and when the why there will be change in pH, because if we are going to dilute it on dilution or on addition of a small amount, we are talking about a small amount. If you will bring large amount, then it will definitely change. Okay. Or on addition of a small amount of acid or base, a solution which resists the change in its pH when you are diluting it or you are adding a small amount of acid or base, that is called buffer solution. Basically, this is of two types, that is acidic buffer and the another is basic buffer. Okay. Now we discussed about acidic buffer. Acidic buffer is a mixture in which weak acid is mixed with either conjugate base of weak acid, or another definition that I told you, weak acid with salt of its with a strong base. Are you getting my point, everyone?
Yes sir.
So basically,
Yes, sir.
if I'm going to take an example, I just took an example CH3COOH. So if it is mixed with conjugate base of it is basically we just remove H plus. If we are just if you will just remove H plus, it will be left with CH3COO minus. This is conjugate base. Okay, so the mixture of this is acidic buffer because here it is weak acid and its conjugate base, or you can say CH3COOH plus you can take the salt is prepared by the reaction between acid and base. in which the acid is this weak acid and the base should be base should be basically from a strong. So this acid will react with a strong base. Just take it NaOH. So the product will be CH3COON. The product will be CH3COO Na and H2, neutralization reaction. You can see this is the salt with its acid, weak acid and a strong base. So the mixture of CH3COOH plus CH3COO Na is acidic buffer. Everyone okay with this? Saif,
Okay,
Yes,
Arsalan,
sir.
Fawaz.
Yes, sir.
Yes, sir.
Okay, thank you. This buffer solution is very, very important. Okay, so I gave you all the examples only. Now I'm going to give you question. Question is, which of the following shows which of the following are, why it is is my voice lagging or breaking?
No, sir.
No,
Okay. What about the video?
no, sir. It's also
So sometimes it's like a little lag, sir. Not always.
Okay, thank you. So which of the following are acidic buffer? A is basically I'm going to give you and then tell me which one of the following or mixture between this. Wait a minute. It's now it's okay. Which of the following are acidic buffer? C and D. Again, check it. Okay, for us, one of the option is wrong. Any other answer from any other student? You have to check it, each one of them. Otherwise, you won't get it. Ifra.
Sir, can you help solving, sir?
Okay. I'm going to take the first example, this. Okay. The first question. What you are going to do is look at the mixtures. This is NaHCO3. What is this? You can say it that it is salt, right?
Yes,
Can you
sir.
say it, is it salt? Saif, Ifra?
Yes, sir.
Okay. Now, if you are saying that it is salt, if you are going to mix it with water, what will happen? Na plus will dissociate. Yes or no? Just answer me.
Yes, sir.
And
Yes, yes,
what here it will be formed? HCO3 minus. Yes or no?
Yes, sir.
And
yes,
what?
sir.
And if you are going to mix this in water, what will happen? 2Na plus CO3 minus 2 will be formed. Yes or no?
Yes, sir.
Yes, sir.
Now, if you will look at it closely, you will see that this HCO3 minus can give H plus and it will convert it into HCO3 CO3 minus 2. That means what I want to say is that this is weak acid. Is it yes or no?
Yes, sir.
Yes, sir.
Basically H2CO3,
Yes, sir.
carbonic acid is a weak acid, and if it gives one, it will give 2H plus, right? One already given and another will be H plus, so it will be weak acid. Now this sodium will present in the solution, that won't matter for for us. Now look at this CO3 minus 2. This is our weak acid, isn't it? This is conjugate base of this. What is conjugate base? The acid in which we remove H plus, that is conjugate base. Krishna,
Yes, sir.
what is the conjugate base of? If I'm asking what is the conjugate base of HF, then F minus is the conjugate base. So HCO3 minus is the acid. What its conjugate base? Then you will remove H plus, then it will be CO3 minus 2, right? So the mixture of this HCO3 minus and CO3 minus is buffer solution. Are you getting my point, everyone?
Yes, sir.
Ifra,
Yes, sir. Get it.
Saif, Arslan, Fawaz, if you have any problem, any doubt regarding this, please ask me.
Sir, can you repeat again, sir?
Yes, why not? What I told you, that you have to look it closely. You have to dissociate it so that you will see at the end what you have. You can see here it is NaHCO3 and here it is Na2CO3 minus Na2CO3. If you are looking at this, you will be like this is salt, right? Isn't it? This is salt.
Yes, sir.
Yes,
Yes,
sir.
Now,
yes.
if you will look at this, you will be like this is also salt, but this is acidic salt, you can say, because if you will dissolve this in the solution, it will be like HCO3 minus, like this. And what about this? Wait a minute, please. Sorry. Now look at this. What I want to say is that if you are going to dissolve it in water, it will be like Na plus plus HCO3 minus, and this will be like 2Na plus CO3 minus 2. Okay, Krishna?
Yes,
Sir?
sir.
Now see, this is metal ion, this is metal ion. That doesn't matter for us because it will be in this form in the solution. Okay, and look at this. What is this? Can I say it weak acid? Can I say it weak acid?
Yes, sir.
Yes.
And what is this? Can I say it conjugate base of this weak acid?
Yes, sir.
Saif?
Yes, yes, sir.
So if you are going, this is the this Na plus, that doesn't matter for us here. Now look at this. The mixture of weak acid plus conjugate base of its is acidic buffer. So it will show buffer solution. It is buffer solution. Is this clear, Krishna?
Yes. Yes, sir.
Yes, sir.
Everyone, now look at, will you do second part or I should explain it? Krishna, will you do second part or I will explain? I should explain it.
So better you can explain one more, than the remaining two we can.
So, okay, just look at it. B part. B part is basically HCl and NaCl. Now look at this. HCl. HCl is a strong or weak? Let me know.
So strong.
Strong, sir.
Strong.
Strong
Strong
acid.
acid. And what we have studied in buffer solution, what I taught you is about only acidic buffer, and I will these questions are from there only. Okay, in that we have studied that weak acid requirement. The requirement is of weak acid, not a strong acid. There should be no strong acid, so it will be it is not buffer solution.
Yes, sir.
Okay.
Safe. Safe.
Yes, sir.
Now see, CH3COOH plus CH3COONH4. First tell me what it is, acid, base or salt?
Salt, sir.
Salt.
Salt, sir.
Now look at this. What is this? Acid, and this acid is weak
Weak
acid,
acid.
right? Now
Yes, sir.
look at this. Salt is prepared from acid and base, right? So then this in this salt, which acid is involved? CH3COOH, right? And
Yes.
which base is involved? NH4OH, ammonium hydroxide. Is this clear, everyone?
Yes, sir.
Yes,
Sir?
sir. Yes, sir.
Now see, what I want to say is that acidic buffer is that in which weak acid plus, if we are talking about, if we are talking about salt, not conjugate base, then salt should be from weak acid plus a strong base. The salt should be from weak acid plus a strong base. Now look at this. This is weak acid and this is weak base. So this it's not buffer solution, because according to acidic buffer, one should be the mixture of two solution. We are talking about always binary solution, mixture of two solution. One should be weak acid and another should be the conjugate base of weak acid, either conjugate base of weak acid or salt of this acid with a strong base, and here what we got is weak base. That's why it's not buffer solution. Everyone?
Yes, sir.
Yes, sir.
If you
Yes,
need
sir.
if you need one more explanation, let me know. I will explain it again. Is this clear?
Yes, sir. It's clear. It's clear.
Yes, sir.
Okay. Now we are going for C part. C part is we just discussed this C part, right? So going for D part, HCN plus AgCN. HCN plus AgCN. What see? What is this? Acid base?
So weak acid.
Weak acid. This is weak acid. And what is this? AgCN?
Salt.
Salt. And salt plus salt of what? AgOH and HCN, right? This
Yes,
is
sir.
the salt of weak acid with weak base. That's why it's also not buffer solution. Remember, whenever it talks about a strong base, that will be from NaOH, KOH, RbOH, CSOH. This all are a strong base. Okay,
Okay, sir.
just write it. Do I need to, should I slide it up? Or
Yes, sir.
okay, from here let me know if you are done with this.
So done, sir.
Very good.
Done, sir.
Wait a minute. Done everyone. Okay. Oh, four. Is this okay?
Yes.
Very good, Ifra. Everyone done with this?
Yes,
Yes.
sir.
Saif,
Yes, sir. Done. Done, sir.
done. Very good. Done, everyone.
Yes, sir.
Saif.
Yes, sir. Done.
Okay. Now do the E part. NaH2PO3 plus Na2HPO3. Done. Very good. Krishna, you answered it right. Very good, very good. For your answer is wrong. What about you, Saf?
1 minute.
Okay. Arsalan, no answer from you. No, hello, hi. Trying cells. Okay, okay, no problem. Should I explain it?
Yes, sir.
Waiting for you, Saf. Just when you will put it in water, it will be converted into N plus, then H2PO3, and here plus 1 goes out, so minus will be like this. And if you will put it in water, it will be like 2Na plus, and it will be HPO3 minus, right, Fawaz?
Yes, sir.
Now you can see that can we treat this as weak acid, because it will dissociate some of its, it will dissociate into H plus. So this is basically weak acid. This is basically weak acid. And what is the conjugate base of it? Conjugate base is what? If you will remove H plus, it will be converted into HPO3 minus. So already this is in solution, and this is, so this is weak acid and this is conjugate base. That's why it is buffer solution, and it is basically acidic buffer. Is this clear, Saf?
Yes.
Very good. Just write it and let me know if you're done with this.
Done, sir.
Done, everyone?
Yes, sir.
Now come to the second buffer. Saif, are you done?
Yes, sir.
Okay. Second buffer, second type of buffer, that is basic buffer. That is basic buffer. In acidic buffer, we required weak acid with with its conjugate base. And another definition, weak acid with salt of this weak acid with a strong base. In the same way, we are going to define it. Basic buffer, it is the mixture of weak base. This is basic buffer, that's why we are taking as weak base, and its conjugate acid, and its conjugate acid. Another definition, it is the mixture of weak base and its salt with, that means with this weak base, its salt with a strong acid. Is this clear, everyone?
Yes, sir.
Just write it and let me know. Then I'm going to explain it with example.
Done, sir.
Done, everyone?
Yes.
Very good. Now, taking example of this, just focus. The base should be weak, so I'm going to take a base which is weak. Weak base with its conjugate acid. What is its conjugate acid? When we will add H plus in this, so it will be NH4 positive. Either the mixture of weak base with its conjugate acid, or the mixture of weak base with its salt with a strong acid. So what I'm going to do is, this is weak base and take a strong acid, that is I'm taking is HCl. So what happened? NH4Cl plus H2O is formed. So here it will be NH4Cl. Is this clear?
Yes, sir.
Yes, sir.
Yes, sir.
Now another example, NH3. NH3 is also a weak base. Okay, so what will be its conjugate acid? Add H plus in this, so it will be NH4 positive. Okay, and if you are going for a salt, then take this weak base with a strong acid. So if you in the same way, if you are going to react NH3 plus HCl, so it will be NH4Cl. It will be NH4Cl, so I'm going to write it NH4Cl. Just write it. Now I'm going to make a list of a strong acid. Always remember it.
Done, sir.
Done, sir.
Done,
Done,
sir.
everyone? Okay. This is basically a strong acid. A strong acid is HCl, HBr, HI, H2SO4, HNO3, and HClO4. It's all are a strong acid. Okay, everyone.
Okay,
Yes,
sir.
sir.
Now see. Now here is the difference between acidic buffer. How we will recognize it is acidic buffer or basic buffer in the solution. If it is given that is this acidic buffer or basic buffer, just remember, go for weak acid or weak base. So weak acid, and here it will be weak base. Either if it is weak acidic buffer with weak acid, it's conjugate base, and with weak base, either it's conjugate acid. Either this condition or weak acid plus its salt with a strong base. It's that means weak with this weak acid, and here weak base, either weak base plus its salt with a strong acid. Is this clear, everyone?
Yes, sir.
Yes, sir.
Can I change the slide?
Yes, sir.
Sir, one
Yes.
minute.
Yes.
Okay, waiting for you.
Done, sir.
Fawaz done.
Done, sir.
Okay. Just tell me. There is a reaction given. Is there any condition that will consider it to form buffer solution? What I want to say is that can they form buffer solution or not?
No, sir.
No. Saif,
So can you ask again what you said?
I'm writing, can they form buffer solution? Yes or no? Ifra,
No, sir.
Fawaz,
सर कैसे कैसे पता लगा?
just look at it. If I'm going to tell you that is this buffer solution? No. But if I'm asking you that can they form buffer solution or not, then my answer is they may be buffer. They may be buffer solution. How it is? How is it possible that this is a strong acid and I am saying that CH3COOH is buffer solution? Okay. Wait a minute. It's both acid basically. I just gave you a wrong answer. Just let me know. What do you think about this? Can they form buffer solution or not? Your answer should be your concept. What you are thinking about this and what I told you. Just give me the answer, whatever you understand till now. Saif, Ifra,
सर no
Then
sir.
no, sir. They
no,
don't.
sir. Just see.
Because it is
Everyone
strong.
will like no, sir, because this is a strong acid and this is salt. This is salt of
Strong.
a strong base plus weak acid, right? And
Yes,
you know
sir.
Yes,
what
sir.
is basically what I want to say is that if you are going to mix it, there will be reaction between these two and it will form CH3COOH plus NaNO3, right? What I told you, they may be buffer solution. There will be a condition. If you are going to take little amount of HNO3 and large amount of CH3COONO, that means this should be the a strong acid where whether it is a strong acid or a strong base. This should be limiting reagent. If it is limiting reagent, then it will be spent in the reaction and it will be empty. It will be empty. Is that clear, Krishna?
Yes, sir.
Saif?
Yes, sir.
And this is in excess. So in the solution, what we have is this salt and this and this. This is what? Weak base. And this is what? This is weak acid plus a strong base. The salt of weak acid plus a strong base. And this is weak base. That means that represents it is basic buffer. There is a condition to form a buffer solution to have basic buffer only if the strong acid is limiting reagent. If it is in excess, then it won't form, or it is equal to this CH3COONO Na, then it won't form buffer solution. But if it is in limiting reagent, then it will have buffer solution. I just proved it because in solution this and this will be present. This doesn't matter for us. Okay, everyone.
Yes, sir.
Just write it in your own language too. If you're done with this, let me know.
Done, sir.
Sir, so the answer will be maybe, right?
Yes, maybe. But in reaction form, there will be given moles from which we can compare that it will be limiting reagent or not. Okay, Krishna.
Yes, sir.
If it is it done? Is it done? Saif, Ifra, Fawaz.
Yes, sir. Done.
Very good.
1
Saif,
minute, sir.
okay, take your time, Saif.
Yes, I finished.
Okay, everyone. Now, let me know. Will it show? Is it buffer solution or not? Solve the above question. I'm going to write the conclusion first. In acid base reaction, if a strong acid, SA stand for a strong acid or a strong base, are limiting reagent, then it must be buffer solution only if they are limiting reagent. Are you getting my point?
Yes, sir.
Yes, sir.
Let me know the above equation is, the above reaction is, and you don't need to write the product all the time. First you will check it whether it forms buffer or not, then do something about it.
Yes, sir. It's
Sir, it is acidic buffer.
It's already acidic buffer, because if you yes, basically if you are going to, this is weak acid and this is salt of weak acid plus a strong base, so it's already buffer. And you can to be more specific, it is acidic buffer. Very good. Just write the conclusion and let me know.
Done, sir.
done, sir.
Done, everyone. Saif, Fawaz.
Yes, sir.
Yes, sir.
Very good. Now, how we will do the question, if there will be questions like in the form of reaction. So it will be like, if I'm going to give you 10 mole of CH3 COOH, I'm going to explain the first one, then you have to write, then you have to do it on your own. Just see, 10 mole of CH3 COOH plus 5 mole of NaOH. Is it buffer solution or not? So if you are going to write a equation like CH3 COOH plus NaOH, first see, is this forming buffer or not? So if you are going for it, this is a strong base, so it won't form buffer, because in buffer solution we need weak acid or weak base. Now just do the reaction. Acid plus base will give salt plus water, right? CH3, COONA, and H2O. Is this correct? Can you write the equation on your own?
Yes, sir.
Now, see, is this balanced equation or not? Saf, this is balanced or not? Fawaz, is this balanced?
Sir,
If
no, sir.
what you just said, yes or no?
No, no,
Yes,
no.
it's balanced.
It's balanced. It's balanced. Wake up, Fawaz.
Sir,
Now see, if it is balanced, you can see 1 mole of this. How I am saying 1 mole of this? The stoichiometric coefficient of CH3COOH is 1. That means 1 mole of this required to react with 1 mole of NaOH, right? And in the question, it is given that this is 10 mole and this is 5 mole. Is this clear, everyone?
Yes, sir.
Yes, sir.
Now,
Yes,
1
sir.
mole of this required 1 mole, and here it is 10 mole, and here it is 5 mole. That means if this is lesser in amount, that means this is limiting reagent. Are you getting my point, Mohammed, Saif?
Yes, sir.
So this is limiting
sir.
reagent. That means it will be over. It will be totally converted into product. Now we have in a solution, what we have in a solution is this is in excess. Just see, 1 mole of this required 1 mole of this. Now 10 minus 5, that will be equal to 5, and here 5 minus 5, that will be equal to 0. Is this clear? And here
Yes, sir.
5 mole of this is formed. Here 5 mole of this and 5 mole of this is formed. How? 1 mole of this react with 1 mole of this to form 1 mole of this and 1 mole of this. Is everything clear, everyone? Krishna?
Yes,
Yes,
sir.
sir.
Now what I want to say is that what is remaining in the solution is 5 mole of CH3COONO, sorry, CH3COOH, that is weak acid, and this is also left in the solution. This is salt of weak acid plus a strong base, right?
Yes, sir.
And in the solution water is present, so we don't care about water here. So basically this is buffer, and what which type of buffer? Isn't it acidic buffer? Krishna, Saif, Ifra?
Yes, sir.
Yes, sir.
Yes, sir.
Thank you. Write it. Done.
Done, sir.
Saif, Fawaz, Krishna.
sir, 1 minute.
Okay.
So they will ask this for how many marks?
It will be 1 or 2 marks.
Okay, sir.
Done, sir.
Very good. Saif,
Yes, sir. Done.
everyone done with this? Now,
Yes.
I'm going to give you some questions. On this base, you have to do reactions, then check whether which one of them is limiting reagent, then write about it, whether it is acidic or basic buffer. So the second one is basically 5 mole of HCN plus 3 mole of KOH. The third is 10 mole of HCOOH plus 4 mole of barium hydroxide. Everyone done? Krishna,
So I finished the first one, so I'm doing the next one.
okay. What about the first one? Is it showing buffer? Is it buffer solution?
Yes, acidic buffer.
Okay. Seth, I'm expecting answer from you too.
Sir, can you write the equation for third one?
Third one. Have you solved the first one?
Yes, sir. I got an acidic buffer.
Okay. So if you are going for this, I'm going to give a better explanation of this with the help of this HCN plus KOH. Okay, Seth. Whenever
Yes,
you
sir.
have doubt in this, just think OH in aqueous solution, it will be in OH minus, right? OH
Yes,
minus.
sir.
So everyone concentrate here. If you will have problem in writing equation, just mark it as minus and K will be in positive, K plus, right?
Yes,
Yes, sir.
sir.
And this is, if this is acid, hydrogen will go in H plus and this whole is in negative, right, everyone?
Yes, sir.
Now
Yes, sir.
positive will go with negative, negative will go with positive, so equation will be KCN and here it will be H plus OH will give H2O, right?
Yes, sir.
So remaining you already did that. This is acidic buffer, right? Fawaz, is there any doubt in the question number second?
No, no, sir.
Okay, now if you are going to write this equation for this, just see BaOH whole twice. Do you know Ba is what? Name of Ba? Can you name?
Barium.
Barium. Now see, OH has negative charge, and if there is 2 OH, that means total charge on OH is minus 2 total charge. I am talking about total charge. Is it correct, Krishna?
Yes, sir.
Yes, sir.
Saf? Now, If and you can do, are you seeing any charge on this molecule? Yes or no?
No, sir.
No,
No.
sir.
Total charge on OH is -2. That means this has +2 charge, and this we always represent. Wait a minute. We always represent charge uh, charge of one atom or one molecule. So this is -1 and this is +2. And if you are going for this HCHO, HCOOH, that is acid, that means it will give H plus, that is +1, and here it will be -1, right? Saif, Krishna.
Yes, sir.
Now
sir.
I already told you that this minus will go with plus, this plus will go with minus, and you can see this is H, this is OH. It will give H2O. Is that clear?
Yes, sir.
Now
Yes, sir.
what I want to say is that magnesium has +2 charge. How magnesium and chlorine react? How magnesium and chlorine react? Chlorine has 1, magnesium has 2. So it will be like this, and it will be MgCl2, right?
Yes, sir.
Now this barium has 2, and this HCOO has 1 charge, right? Saif.
Yes, sir.
So if you are going for this, the formula will be BaHCOO whole twice. Is this correct?
Yes, sir.
Saif, is there any problem now?
No, sir.
Now see, the main thing is that you have to balance the equation. What I told you is that balance the equation. Balance the equation. So if you are going for balancing the equation, you will see HCOO is twice here, so you have to put 2 here. Now 2 mole of this will give 1 mole of this, 2 mole of this combined with 1 mole of this. So or you can see 1 mole of this will combine with 2 mole of this. So you are seeing here only 4 mole. That means here 8 mole will be used. So 10 minus 8, 2 moles will be left. Is this clear?
Yes,
Yes,
sir.
sir.
And here 4 mole will be formed. 4 moles. So in the equation, what we have is weak acid, that is HCOOH, and you can see weak acid, and this is weak acid with weak base. Just check it out. A strong base and weak acid. From here, a strong base and weak acid. That's why it is acidic buffer. Okay.
Okay,
Yes, sir.
sir.
Okay, just write it and let me know.
Done, sir.
Everyone done?
Done,
Saif,
sir.
Yes, sir.
Saif, are you done?
Yes, sir.
Okay. Moving to the next question. Five mole of NH4OH plus 2 mole of HCl. If you are done with this, let me know.
So it is basic buffer.
Is it basic buffer? Any other answer? Any other answer, Krishna?
Yes, sir. It's basic.
Saif?
Yes, sir.
Okay. For us, no answer. I have to call everyone's name, then you will speak up. NH4OH combined with HCl will give NH4Cl and then H2. At first, if you will see a strong acid, then you will call it like it's not buffer solution. But if you are going to see this, 1 mole of this combined with 1 mole of this, and here it's 5 mole is given, and here it is 2 mole. So 2 mole of this will combine with 2 mole of this, 3 mole will be left with. 3 mole of this will left. So NH4OH in the solution and NH4Cl. And what is NH4Cl? Basically, this is for weak acid and a strong base. Sorry, weak base and a strong acid. A strong acid. And this is weak base. That's why basic buffer. Everyone done with this?
Yes, sir.
Yes, sir.
Yes, sir.
Now going for next. (20 mole of HNO3 plus 6 mole of NH3.
Sir, I'm having some trouble in forming the equation. Can you
Forming
please?
the equation, right?
Yes, sir.
Okay, just look at it. What is this? Acid, and what is this? Base, right?
Yes, sir.
Now the product will be NH4NO3. This is the salt we have. Okay.
Okay,
If
sir.
water will be present, then H2O will be there. You will see like this, it will be, this is negative, this is positive, and this has basically like this. So this will give electron to this, so it will form NH4 positive, it will form NH4 positive, and here it will be NO3 minus, so this will combine to form NH4 NO3. Okay.
Okay, sir.
See, this is a strong acid. Now 20 mole of HNO3 will combine with 6 mole of NH3. Will it form or not? What do you think? Are you done?
So is it basic buffer?
Any other answer? Ifra, Saif, Fawaz.
Sir, basic buffer.
Yes, sir.
Yes, sir.
Who is this Ifra? Is it?
Sir, she is my sister and she shouts intensely.
This is 20 mole of HNO3. This is 6 mole of this. What do you see is 1 mole of this combined with 1 mole of this to give 1 mole of this, right? What is
Yes.
limiting reagent in this? This is the LR, right?
Yes, sir.
So what is left in the solution is a strong acid. So no buffer solution. Na? Krishna, Saif, Fawaz, Ifra.
So can you repeat
Say,
the
can you say it again?
Yes, why not? Tell me whatever I am going to ask you. Which one of the following is limiting reagent?
NH3, sir.
NH3. NH3 is weak base. And what is it? Acid or base?
Sir, acid.
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 What type of acid? A strong or weak?
Strong.
Strong acid.
Strong acid. This is LR. This is LR. That means it will be completely converted into product. That means at the end of the reaction, this will be 0, right? So what will be left in the equation is a strong acid or a strong acid with salt of a strong acid plus weak base, right?
Yes, sir.
And according
Yes,
to,
sir.
if you are going with this, according to basic buffer, there will be weak base, or according to acidic buffer, there should be weak acid, not a strong. So no buffer solution. Are you getting my point?
Yes, sir.
Okay, just write it.
Done, sir.
Done, everyone.
Yes, sir.
Yes, sir.
Okay, very good. Now write a equation. Just write a topic. Henderson's formula for buffer solutions. Henderson's formula for buffer solutions. Okay. What is Henderson's formula? Basically, it is used to calculate pH. So pH equals to, for buffer solution, pH equals to pKa plus log of conjugate base, that is A minus, in the numerator upon acid. The acid which you are using in the denominator and its conjugate base in the numerator. Here, how we calculate the buffer solution's pH. And this equation is known as Henderson's formula for buffer solution. Do you know what is pKa?
No, sir.
No, sir.
Okay. And in terms of pOH, we can also write pOH equals to pKb plus log of, here it is base B and its conjugate acid, that is BH plus.
Sir, in the first equation, what is HA, sir?
What is
Sir, HA, you wrote.
HA? That is acid. HA, acid. HCl, it can be any acid.
Okay, sir.
Okay. Very good, Arslan. If you are done with this, let me know.
Done, sir.
Done, sir.
Okay. Now see, if you will have value of K increasing, that means acidic character. Also,
Sir, can you show the equation once more again?
yes, why not? You should speak up when everyone is saying done. Okay, Saf, so that I will not slide it up.
Yes, sir. Done.
Very good. Everyone done with this?
Yes, sir.
Yes, sir.
Wait a minute. Now you will see that if I am going to what I just wrote here. Wait a minute. Yes, here it is. If the value of K is basically dissociation constant of acid. We will talk about it after some while. Just write a topic, Ostwald dilution law. Ostwald dilution law, and hold it for Ostwald dilution law. Then we will discuss basically what is pKa, what is Ka, what is pKb. Okay, everyone. Saif, Krishna,
Yes, sir.
Okay.
is there any doubt in Henderson equation? You will have value of, this is basically, this square bracket represents molarity, concentration. You can easily put the value here and here. Okay, then solve it. It will be in the form of log, and we discussed how to calculate the value of log, right?
Yes, sir.
And the value of pK will be given, just put it and just you have to calculate the, and you will get its pH or pOH, whatever is the question. Okay, so can we move to the next part, Ostwald dilution law?
Yes,
Yes,
sir.
sir.
Now, what is Ostwald dilution law? The first point, which is very important, is it is applicable. It is applicable for weak electrolyte only. Weak electrolyte. In the first lecture of ionic equilibrium, I told you what is weak electrolyte and what is a strong electrolyte. Just see here, we have a acid. Just suppose we have a acid. So if you put it in water, it will dissociate into ions like H plus plus A minus, right?
Yes, sir.
Now see, just suppose C is the initial concentration. Initially, the concentration of H plus and O minus will be 0, 0. But after some time, it will dissociate. When it will dissociate into ions, it will be C minus X, X, and here X will form, and here also X will form. Is this correct?
Yes, sir.
Now, here alpha is very important. In the first lecture, I told you about dissociation, that value of alpha. Do you remember, Saf, Krishna, Ifra? First lecture of ionic equilibrium, in which I told you that if alpha is equal to 1, that means alpha is equal to 100%. That means total reactant is dissociated or converted into product. Krishna, am I
Yes.
audible?
Yes, sir.
So alpha is very important. With this, with the help of alpha, we actually can come to know how many moles or how much concentration of product is formed. Is that clear?
Yes, sir.
So alpha has a
Yes.
formula, that is alpha equals to moles converted, basically moles converted, that is X upon initial moles. Initially, what its moles is C. So we can easily find out the value of X, that is X is equal to C alpha. What is the formula of alpha? Alpha is equal to moles dissociated upon initial moles, and we can get the value of X. X is equal to C alpha. Is this clear, everyone?
Yes, sir.
Now see, I can write C minus C alpha. At the place of X, I can put C alpha, and here C alpha 2, and here C alpha 2, right?
Yes.
Yes, sir.
Now, going to write the value of Kc, like we did in chemical equilibrium. Kc equals to, for this reaction, it will be H plus into A minus upon HA. Now, putting the value of H plus, that is C alpha, and here A minus C alpha upon C minus C alpha, and solving it, it will be like C square alpha square upon, if we are going to take the common C, take common as C, it will be 1 minus alpha, and here's 1 C will be cancelled. So Kc equals to basically C alpha square upon 1 minus alpha. Is this correct?
Yes, sir.
So we got Kc is equal to, that is C alpha square upon 1 minus alpha. Just write it till then I'm going to explain it again. Okay. Just let me know when you are finished.
So can you scroll down?
So you all were writing with me, right? Saf,
1 minute, sir. Please go up.
what you just said, Saf? 1 more minute or
Please scroll up, sir.
okay. Let me know. Is it good?
Yes, sir.
Okay.
Done, sir.
Done, everyone.
Yes.
Fawaz,
Yes, sir.
Saif.
Sir,
Sir,
done.
can you go a little down?
Just write it. Very good, Ifra. Done, everyone.
Yes, sir.
Saif, Fawaz,
Yes, sir, done.
Saif.
Yes, sir, done.
Now see, what I want to say is that this HA is basically acid, so we use Ka instead of Kc. This Ka, this Ka is basically dissociation constant for acids. So Ka equals to, we can easily write C alpha square upon 1 minus alpha. Is everyone okay with this? We just replaced Ka with Kc with Ka. Is everyone okay with this?
Yes, sir.
Yes, sir.
Now see, as we know that we are calculating for weak electrolyte, and we know that weak electrolyte alpha is 5%. That means alpha has a value 0.05, which means alpha is very, very less than. This is maximum value, basically 5%. Alpha is basically less than this. This is the maximum value. Alpha is very less than 1. That means this alpha is very less than 1. If we will uh, subtract alpha from 1 and the value of alpha is very, very less than, then it won't affect the value of 1. So basically we neglect it, and Ka is equal to C alpha square we will get. Is everyone okay with this?
Sir, can
Yes,
you
sir.
repeat?
Alpha is very, very less than 1 because alpha, we are going for weak electrolyte, and in the first lecture I told you that alpha is equal to 5%. This is the maximum value. Alpha means dissociation. That means acid or base or any electrolyte converting into product, into its ions, that is very, very less. That dissociation is very, very less. If you have 1 mole of weak electrolyte, it will be converted into product. This is the maximum value I'm talking about, and it is very this is the maximum value. That means the alpha has uh, less value than this. So what I want to write here is alpha is very less than 1, very, very less than 1. So if you are going to subtract 1 minus 0.005, will it affect the value of 1? The value will be very, very near to 1. So I just neglected alpha. Okay, everyone.
Okay, sir.
Okay,
Yes,
just
sir.
write
Yes,
it.
sir.
Okay, just write it.
Done, sir.
Done, everyone. Saf.
Yes, sir. Done.
No, 1 minute, sir.
Okay, take your time, Saf. We will have some more concept on this base, so just write it. So can anyone send the syllabus of your upcoming exams and the date of exams too? The final exams and any other tests you have, please send it to Nishkar sir. Okay, Krishna.
Okay, sir.
Everyone send their own date sheet. If the date sheet are same for all of you, that is good. But if they are different, let me know. And please let me know the deleted syllabus.
Okay, sir.
Okay, can I change the slide now, Saif?
Yes, sir.
Now see, we got the value Ka is equal to alpha. What just happened? We got the value Ka is equal to C alpha square, and here alpha equals to under root of Ka upon C. Can I write it or not?
Yes, sir.
Everyone, this is the
Yes.
value of alpha. Now I can C is basically what? C is concentration, right? Ifra,
Yes, sir.
C is what? Concentration of reactant that is converted into product. So C is concentration that represents basically molarity, and for molarity we know that number of moles upon volume of solution. Is this clear, Saif?
Yes, sir.
Now
Sir.
we just took number of moles as 1 and volume V. We just took number of moles as 1 and volume V. So I'm going to put this value in this equation. So what we will get is very important. What we will get is very important. You can see alpha is equal to under root of Ka upon 1 by V, and you will get alpha is equal to under root of Ka into V. We will get or not?
Yes, sir.
sir.
Just write it.
Done, sir.
Done, everyone?
Yes, sir.
Done, sir.
1 minute.
Just a second.
Okay, take your time.
Done, sir.
Done. Very good.
1 minute, sir.
Okay. Everyone done with this?
Yes, sir.
Now see, I didn't tell you till now that what is basically Ostwald dilution law. First we are going to understand. I just did it all this for acid. Now in the same way, just suppose this is base, and if you are going to put it in water, it will be converted into B plus OH minus and B plus OH minus, right? Just let me know. Is this clear?
Yes, sir.
Now in the same way, just suppose starting at the starting, this has a concentration C. Initially this will have 0 0. So in the same way, it is dissociated minus X, so it will be XX. In the same way, the value of X we got in acid is C alpha and C alpha, and it will be C alpha. In the same way, Kc has a value B plus into OH minus upon BOH. In the same way, what we got, B plus has C alpha into C alpha upon C minus C alpha. In the same way, C square alpha square, and we will take C as a common, 1 minus alpha, and it will be, you can see one C will be cancelled, and here it will be, wait a minute, here it will left with C alpha square upon 1 minus alpha. This the value of Kc. Since it is base, so we are going to replace it with Kb. Kb equals to C alpha square upon 1 minus alpha. Write with me, it is the same as the basic, as the acidic. Okay.
Yes, sir.
Now you will see this Kb is dissociation constant for base. Dissociation constant for base. Okay. In the same way, alpha is very, very less than 1. So Kb will be equal to C alpha square. In the same way, alpha has a value that will be equal to under root of Kb upon C. In the same way, we know that C is equal to N by V. We took number of moles as 1 by V. So alpha equals to basically under root Kb into V. I just wrote it directly. Should I slide it up? Should I slide it
No,
up?
no, sir.
No need, sir.
Okay. If anyone needs, let me know. Done, everyone.
Yes, sir. Done.
Saif, Ifra.
Yes, sir, done.
No, 1 minute, sir.
Okay. Fawaz, what is this? कब क्या है?
नहीं कब नहीं, केवी क्या है?
Kb dissociation constant for base. Ka is dissociation constant for acid. For acid, we use Ka instead of Kc. For base, we use Kb instead of Kc. Is this clear now?
Yes.
Okay.
Yes, sir. Done.
Very good. Now I'm going to write what is exactly Ostwald dilution law. So write with me. According to this law. Which law?
Ostwald's
Ostwald's
dilution.
law. Yes. Alpha is basically degree of dissociation. Sometimes I made mistakes to remember it. I told it maybe degree of association, not degree of association, as dissociation constant. I told it that is wrong. Basically, alpha is degree of dissociation in the previous class. Maybe. According to this law, the law, sorry, according to this law, the degree of dissociation, I am writing DOD. DOD stands for degree of dissociation of weak electrolyte just write it, please. So according to this law, the degree of dissociation of weak electrolyte is inversely proportional to their square root of concentration or directly proportional to the square root of dilution. The square root of dilution. Just write it. Then, very good, Arslan. Then I will explain it.
Done, sir.
Okay. Now see, everyone done with this, Saf?
Yes.
Yes, sir.
Okay, thank you. Just see what we have. Alpha is equal to basically Ka upon C. And also alpha is equal to under root of Ka into V. So if you increase concentration, alpha will decrease. That means the dissociation, degree of dissociation will decrease. That means the reactant is converting into product will be decreased. Am I clear?
Yes, sir.
Now, according to this law also, if we increase volume, alpha will increase. That means if we increase volume, that means the solution, that means if we are going to do dilution, then the degree of dissociation will increase. Is it? It is simple. Okay.
Yes, sir.
Okay. Thank you, everyone. I will end this class today because I'm not feeling well. Okay. If you have any doubt,
Okay, sir.
discuss in next
Okay,
class.
sir.
Okay. Thank you so much. Okay.
Okay, sir.
Okay. Do you have any doubt?
No, sir.
Okay. Thank you.